All right, notes 14, Pythagorean reciprocal and quotient properties. So I think most of you guys already know these three. So I think we're cool with those. Those are reciprocal properties, right? So make sure, since they're reciprocal properties, we also know that cosine x is equal to 1 over secant x, because that's the same thing, they're reciprocal properties. Sine x is equal to 1 over cosecant x, and tangent x is equal to 1 over cotangent x. And then remember, guys, anytime you multiply by the reciprocal, you're just going to get 1, right? Because it makes sense. So if you have cosine x and you're multiplying it by secant x, that's just 1, right? Because cosine x and then secant, what did we say secant was? 1 over cosine? See? The cosine x just cancel out. And it's just 1 anyways. So that's just for you guys to know. And then we know that tangent is sine over cosine, and cotangent is cosine over sine. Just a reciprocal of that. Anything crazy? Does anything not make sense? Pretty simple, right? Pretty straightforward. All right. So on this one, where it says transform sine x cotangent x into cosine x, all they're trying to tell you is they're telling you that sine x cotangent x is cosine x. So check it out, guys. All you're gonna do, sine x, and then you're gonna write. Well, I guess I'll write cotangent x right now like that. We're trying to prove this. Here's what we want to prove. So how do we prove it? I'll write sine x, and then cotangent x is cosine x over sine x. And then look at that. Sine x and sine x, these two cancel out, and you just get cosine x. See? Straightforward. And then we just write a little statement. We put 3 little dots. The 3 little dots is like saying therefore. Therefore, sine x cotangent x is nothing more than cosine x. And then that's it. We're done. Make it quick, man. Make it quick. Yes?
How did you get that little fraction of cos x on top of sine x?
From right here. Cotangent x is cosine x over sine x. Ask me, guys. Ask me questions. What questions do we have? Hit me. Oh yeah, these were just the properties. So I just rewrote them. Cosine is 1 over secant. Okay. Cool or not cool? Okay. So go to the next page. And I know we have a whole bunch of blankness. That's on purpose. It's by design. Draw the first quarter of the unit circle. Just the first quarter. Like so. Oh, you can write it big if you want. Here is my right triangle for this unit circle. Here is that angle, theta. I have some coordinate, some x, some y. Here's my hypotenuse of 1. This is some x value. This is some y value. We haven't done anything crazy. All right, SOHCAHTOA. And I know from Pythagorean theorem, I know that x squared plus y squared, bless you, equals 1 squared. Are we okay with that? Okay. Since we know that's a fact, 1 squared is just 1. I'm going to rewrite this as x squared plus y squared equals 1. Next, well, let's see. What do we got next? We know that sine of this angle is just opposite over hypotenuse, so sine is just y. We know that cosine of this angle is just adjacent over hypotenuse, so it's just x. And we can do, say, tan is y over x, but tan does not play at this moment. And then I'm going to substitute. X equals cosine theta, so I'm going to write cosine theta squared plus parentheses sine theta, close it, squared equals 1. Are we okay with that statement? So from there you can say cosine squared theta plus sine squared theta equals 1. And remember that cosine theta with a square on the outside equals cosine squared theta. Do not write this. Do not write cosine theta squared like that. That's the theta that is squared. So that does not equal cosine squared theta. Those are not the same. If you want them to be the same, put parentheses. Are we okay so far? Nothing crazy, right?
What says cosine theta squared equals cosine squared theta?
There's a slash through the equal sign.
Oh, the one next to it.
That says cosine theta, the whole thing squared, equals cosine squared theta. That's what this means. That means this. This is a theta. No, that's nothing. That's like saying x squared is x squared. It's just a statement. You know what I mean? So what I'm trying to say is don't put the square on the argument, because then it looks like it's, if you put the square on the argument, you're telling me that it's cosine theta squared. It's not cosine squared theta. You know what I mean? Yeah, the square is inside, it's cosine squared plus sine squared. Okay. Half joking, half kind of serious. This cosine squared plus sine squared equals 1, guys. Valentine's is coming up. And if here's what you're going to write. You're going to write a poem. And if they don't get it, just break up with them. Here's what you're going to write in that poem. You're going to say that you're cosine squared and your significant other is sine squared. And together you guys are 1. And if they're like, huh? Just break up with them. Get yourself upgrade, you know? I do know, this is a true story. I do know of 2 math teachers who one has a cosine squared in his wrist, and then the lady has a sine squared on her wrist. And he's a consultant for College Board, and his wife is another math teacher who knows where. And so I think that's pretty cool. So there it is. Use that in a poem. So who said that math can't be romantic? All right. On the side, put bullet. Cosine squared plus sine squared equals 1. That is 1. It's called a Pythagorean identity. Pythagorean trig identity. This is a Pythagorean trig identity. So I'm going to rewrite it because I'm going to do something to it. I'm going to go ahead and divide all 3 of those terms by cosine squared to transform it into something else. These are the 3 most common ones that we're going to do. Cosine squared over cosine squared, that's 1. 1, that's an arrow there. Plus sine squared over cosine squared. Well, sine over cosine is tan. Because I have a squared, put a square on it. And then 1 over cosine, that's just secant. And then because cosine has a square on it, put a square. And that's my second bullet. So go to second bullet and write 1 plus tan squared theta equals secant squared theta. This is called a Pythagorean trig identity. Yes, miss. There should have been one on your desk. There's one right there. Oh, no. Yes.
Why are you going to divide all of it by x?
Oh, to get my second identity. As long as I divide all 3 terms by cosine squared x, it's still the same. Like it's still, the left still equals the right. I'm just deriving identities, miss. I don't want to be a robot. Like, I could very easily just tell you this and just say, just use those, and then you wouldn't know like where they come from. Like, I don't know why. Okay, I'm just going to use them. So I'm just deriving them. There's one more. So here we go. I'm going to rewrite it again. Okay, does everyone know that all of these are derived from the cosine squared plus sine squared equals 1? We're going to call that the Valentine's formula. Don't call it that with a professor. He's going to laugh at you or she. It's not called the Valentine's formula, but we'll call it that. Are we okay? Now, instead of dividing everything by cosine squared, guess what I'm going to divide everything by now? Sine squared. Why am I doing this, Reese? I'm doing this because I want another identity that's very popular. So when I do that, cosine over sine, that's the same thing as cotangent, put a square on it, plus sine over sine, that's just a 1. And then 1 over sine, that's cosecant. And put a square on it because it's 1 over sine squared. And this will be my third Pythagorean trig identity. cotangent squared theta plus 1 equals cosecant squared theta. Are we okay? Okay. Guys, I know there's a lot going on today, and I'm not trying to, because sometimes it's out of your circumstance and you can't do anything about it. But today, I think like half the class was here pretty late. Now, I'm not telling you that you can't what to do, because you can do whatever you want. But if you're struggling in this class, the last thing you want to do is be late. So if you don't know what's going on and then you come in 10 minutes late or 5 minutes late, then you're not going to know what's going on at all. And I can't help you the more behind you get. So some of you are just digging yourself in the hole. And this doesn't apply to everyone. It's just, like if you want to help yourself by being here on time. And because I start at 2:15 exactly, guys. So just a heads up. So don't get mad at me. I'm just letting you guys know, like I'm trying to help you out. Okay. So these are the 3 Pythagorean trig identities that we're going to use. So if you want to Google it later on tonight, here it is. I'm spelling it out for you. Pythagorean trig identities. Pythagorean trig identities. Okay. When will you use them? Well, whenever it comes into, turn the page. You use them with something like this. So notice this one says cosine squared minus sine squared into 1 minus 2 sine squared. So they want me to transform. They want me to show this. So they want me to prove this. They want me to prove that. So how do I prove this? Well, I want you to observe. Notice that the right-hand side does not have any cosine squares in it. Do you guys see that? So on the side, we've only learned one thing today, right? The trig identities. On the side, I'm going to write side note, and I'm going to write, well, I know that cosine squared x plus sine squared x, I know that equals 1, right? And what I'm going to do is I'm going to get cosine squared by itself. So I'm just going to move the sine squared to the right. So I'm going to go cosine squared x is equal to 1 minus sine squared x. Are we okay with that statement? I haven't done anything crazy. I'm going to use this. Chav, what do you mean? Here's what I mean. You see how I have cosine squared minus sine squared? I'm going to rewrite it. So here we go, parenthesis. In the parenthesis, I'm going to write what cosine squared is. What's cosine squared? Yeah, 1 minus sine squared, right? And then this minus is this minus. And then sine squared x. I haven't done anything crazy. You see those parentheses? There's nothing in front of it. I can just drop it. And then look, I have 1, 2 sine squares. Do you see how you have 2 of them? So because I have 2 of them, I can rewrite this and then write 1 minus 2 sine squared x. Did I prove that the left does in fact equal to the right? Cosine squared minus sine squared equals 1 minus 2 sine squared. Yeah, so you write 3 little dots in the shape of a triangle. That means therefore, cosine squared x minus sine squared x does in fact equal 1 minus 2 sine squared x. Done. And there it is. You just proved that in fact really is that. How do we feel, guys? Not bad, right? It's kind of like a little puzzle. The more you do, and it's kind of fun. It's kind of fun. So, in life, are you ever going to be doing this in life? I don't know. Probably not, unless you're an engineer. If you're an engineer, you're going to be working with signals all the time, so you'll be working with this all the time. But in life, so why are we doing this? The whole point of this, guys, is can you figure out the problem? Can you figure out the processes on the why? How you go from one to another? That's what you're going to use every day in real life. Every day in real life when you're the boss and, how do I make sure to make a profit? How do I figure out a model for how much revenue is coming in? Just because revenue is coming in doesn't mean that you're making money, right? Because there's costs associated and you have to derive all these models and everything. So that's what you're going to use every day in real life, guys, the critical thinking. All right, so it says prove algebraically that 1 plus cosine x times 1 minus cosine x equals sine squared x is an identity. Okay, here's what you do. 1 plus cosine x, I'm rewriting this, and then 1 minus cosine x. I'm going to go ahead and distribute that. So I'm going to go 1 times 1, and I don't like using the word FOIL because I'm not a big fan of FOIL, first in out, last or whatever, first out in last. 1 times 1, 1. And then I just keep going with that 1 until I multiply everything on the other term. 1 times negative cosine x. Negative cosine x. And I know some of you are saying, Chav, it's a difference of squares. That's just 1 minus cosine squared. Like, yeah, you're right. But for everyone else, I just want to make sure that they can see it. What's cosine x times 1? Cosine x. What's cosine x times negative cosine x? Yeah, there's 2 of them, so say cosine squared x. Cosine times cosine is cosine squared, and then x is just the argument. Nothing crazy, right? What zeroes out? Yeah, look, I have a negative cosine x and a positive cosine x. That zeroes out, and I have 1 minus cosine squared x. And I know what you're thinking. You're like, Chav, I haven't proved anything. Now from here, I'm stuck. I don't know what to do. Side note. You go over here to the side, and you write side note, and you write the only identity you know. You know the trig identity. Well, you know 3 of them, but all of them are derived from this one, from the Valentine's formula. Cool or not cool? And then you're like, wait a minute. Look at that. I can get cosine squared by itself, or I can get sine squared by itself. Maybe that one's easier. If I just move that to the side, and then I get this. Notice that that's a 1 minus cosine squared. Do you guys notice that? Isn't that 1 minus cosine squared? And what does this say that it's supposed to equal? That equals what? Yeah, that equals sine squared. Look at that. And look, did we just prove that 1 minus cosine squared is in fact sine squared? Yeah. You can just put 3 little dots in a triangle. And then you can say that means that 1 plus cosine x times 1 minus cosine x is in fact sine squared x. Does that make sense, guys? And you can connect them right here if you want. Put an arrow back and forth from your side note. What do you guys think? It gets more fun. Maybe that one's not as fun as you would like for it to be. Question number 4 is kind of fun. I kind of like that one. For example 4. Don't worry, we're almost done, guys. We got only 2 more examples. And then we'll do 2 together from or maybe even 3. All right, prove algebraically that cotan A plus tan A equals cosecant A, secant A is an identity. Okay, so here we go. I'm going to write cotan A plus tan A. And I want that to be cosecant A, secant A. That's what I want to prove. I'm going to go slow, guys. You guys ready? Cotangent is what over what? Okay, but instead of x over y, tell me. Yeah, cotangent is cosine over sine, and then tangent is sine over cosine. So that's what we're doing. So I'm going to come over here, and here's what I'm going to write. Cotangent. I'm going to write cosine A over sine A. That's what cotangent is. Plus, that plus is this plus, and then tangent is what over what? Yeah, you got to keep the argument, whatever that argument is. Every time you hear me say the word argument, I'm talking about the letter, that letter. Sometimes they put parentheses, sometimes they don't. Are we okay with that? Okay. The only way to add those 2 terms up is to get something called a common denominator. Do you guys remember that from your elementary days? So I'm going to multiply this term on the left by cosine A over cosine A. I'm going to multiply this term on the right by sine A over sine A. And I guess I should have moved the equal sign. Sine A over sine A. When I do that, and by the way, guys, I don't want you to be a robot. Notice that cosine over sine A, this is just a 1. That's just a 1. Anytime you multiply anything by 1, the expression has the same value. Anything times 1 is itself. So I'm not changing the value, I'm just changing the expression. So what's cosine times cosine? Cosine squared. So I have cosine squared over, let me write the sine A first. Sine A cosine A. And then plus, that plus is this plus. And then sine times sine. Sine squared, make sure to put the A over there. And I'm going to write sine A cosine A. So catch up to there and then we'll talk. Now that my denominators are the same, I can write one expression. Well, I can write one line with one common denominator, right? So here we go. I'm going to write cosine squared A plus sine squared A all over sine A cosine A. Can we do that much? Right. And then from there you look at it and you say, well, what else can I do? Look at the numerator. There should be some red flags. Cosine squared plus sine squared, as long as the argument's the same, is equal to 1. That's the Valentine's formula. So 1 over sine A cosine A. So catch up to there. And I know what you're probably saying, like, child, there's nothing else I can do with this. So how am I ever going to get it to look like that? You already have it looking like that. Look, 1 over sine A and then 1 over cosine A. In case you don't know what I'm talking about, I'm going to do something called expanding it. This is the same thing as 1 over sine A. And then make sure it's a multiply, a little dot, 1 over cosine A. See? That's 1 over sine A cosine A. Do you notice that? And 1 over sine A is... that is cosecant A. And 1 over cosine A is secant A. So here it is. I'm going to rewrite it. I'm going to go slow. I'm going to say 1 over sine A dot 1 over cosine A equals, and what do we say 1 over sine A is? Cosecant A. And what's 1 over cosine A? Secant A. Is that what I wanted to prove? There it is. Check mark. You put a little 3 dots in a triangle shape. And you just say the left equals the right. Hence, cotangent A plus tan A does in fact equal cosecant A, secant A. And there it is, guys. How do we feel? Okay. Cool or not cool? All right. Let's go to the next. So is this becoming more fun or no? No? Don't worry, we'll do some together. Ain't no yawning. The next one's a demerit. Well, I know. Some of you probably haven't gone to sleep. Some of you probably went to sleep today, like at 3 in the morning, 4 in the morning. Yeah. Yeah, if I get 3 days off, my sleeping habit will be off. So if you give me 1 week, I'm going to sleep when the sun comes up. That, and as an adult, you just don't want a week off because every day you're just going out, and by the Friday you're like, man, my bank account's low. You know? So we're going out every day. All right. Sorry about that, guys. I'm trying to prove that the left equals the right. You don't have to start with the left. You can start with the right also. So look at the video for first periods. With first periods, I started with the right and I made it look like the left. So here's what you do when you get something like this. I want the left to equal the right, and I notice sine B over 1 plus cosine B. So I'm going to try to get rid of this 1 minus cosine B. So whenever you get something like this, go ahead and multiply by the conjugate. 1 plus cosine B over 1 plus cosine B. Child, why are you multiplying by the conjugate, and why not? Like, I don't understand. Yes, you could have done it. Actually, it doesn't matter. You know what? I'm gonna. Okay, I already started, so too bad. I'll do it 2 ways. I'll do it this way first, and then I'll do it another way, which maybe is the way that you would have gone, and then we'll see which one you guys like better. So if you multiply by the conjugate, child, first tell me why we're multiplying by the conjugate. Okay, first of all, this is 1, so nothing is changing when you multiply by 1. Yes or no? And then the next reason why we multiply by the conjugate is because this looks like difference of squares. And if you remember from your Algebra 2 days, a minus b times a plus b is nothing more than a squared minus b squared. Do you guys remember that? Yeah, so this just continues accumulating, guys, from your Algebra 2 days. If you want to FOIL that, you can. But remember, this is just like difference of squares, so you're going to have 1 minus cosine squared b over, and in the bottom, I would not distribute. You can if you want, but I wouldn't distribute it. Now, Chop, where does this help me? I don't understand. As soon as you see 1 minus cosine squared, you should be thinking Valentine's formula. Side note, I'm going to put it right here. Cosine squared b plus sine squared b equals 1. Look what happens, guys. Move this to the right. Sine squared b equals 1 minus cosine squared b. Do you guys see that? I can just substitute that expression 1 minus cosine squared b, I can just put what for it? Sine squared. Heck yeah. So look, sine squared b over sine b, parenthesis 1 plus cosine b. Are we okay? All right. What's going to cancel? I have a sine squared on the top, and I have a sine b times 1 plus cosine b. You can say it. What's going to cancel? Be brave. Yeah, one of the sines. This cancels with one of those because I have two of them. Sine times sine. I have a product on the top. Does that make sense? I know. Some of you guys are like, I don't know what you're talking about. Okay, side note. Here's what I'm talking about, guys. That sine squared b means this. It means sine b times sine b. That's what it means. Over, I have 1 sine b, and then I have 1 plus cosine b. So this is what I'm doing. One of those sine b's is canceling out. See? That's all you're doing. You're just canceling out one of them. Okay, so that's just a side note for this. So now what do I have? I have sine b over 1 plus cosine b. Is that what I wanted to prove? Yeah, that's what I wanted to prove. Therefore, 3 little dots. 1 minus cosine b over sine b is equal to sine b over 1 plus cosine b. Do you want to see another way? Do I have room? Oh yeah, I got plenty of room. I'm going to go burnt orange. Do you want to see another way? It's up to you. You guys can say no. Okay, here's another way. 1 minus cosine b. So let's say you're like, Chav, I have no idea this multiplied by the conjugate, but I know I got to multiply it by something. Okay, instead of multiplying by 1 plus cosine b over 1 plus cosine b, I'm going to multiply it by sine b over sine b. Because there's nothing else, like there's only a sine b on the bottom, right? So when I do that, look what happens. Go back to burnt orange. I'm going to leave this alone. And on the bottom, sine b times sine b is sine squared b. I come up and I look, where's my side note? Right here. You see this side note that sine squared b is equal to 1 minus cosine squared b? I'm going to replace it. So I write, here's my numerator, 1 minus cosine b, parenthesis sine b, parenthesis, and I'm going to write 1 minus cosine squared b. So catch up to here if you guys are going this route. This in the bottom is the difference of squares. See? 1 times 1, cosine b times cosine b. That's the difference of squares, guys. I can rewrite it as 1 minus cosine b times sine b over, parenthesis, 1 minus cosine b, parenthesis, open, 1 plus cosine b. Now that I have it written like this, I have a product in the top divided by another product. What can I cancel out? The 1 minus cosine b. Bam, bam. And look what you have left. You have left, what do you have left? Sine b over 1 plus cosine b. Is that what I wanted to prove? So as you can see, it all depends on how you want to go, guys. Put 3 little dots in a triangle. 1 minus cosine b over sine b does in fact equal sine b over 1 plus cosine b. Move to the what? Oh, to the side note. You don't have to write anything down, guys. I record all this, you know, right? So you don't have to write anything down. You can just focus on understanding and then just write it down later on. One of my most successful students from years past in 2019, I don't want to call her out because maybe, but that's what she would do every day. She would not write any of it. She would just listen. And then she'd be like, okay. And then she would watch the video to rewrite her notes. Sometimes she, you know, if she would get tired, she would just ask for a copy of this. Can you email me this copy? I'm like, yeah. And she would print it out on her own. Like, you know, sometimes if she was too tired, she would just print it out already like this. Like she would ask for this copy here. And which is fine, but I would say 75% of the time she would redo it, and then 25% of the time I would just send her the copy. And yeah, see, so you can just request one of these, or if you want, I can upload this filled in into Canvas, and you can just take it from Canvas. Well, I'm going to start doing that. Okay, look at your activity that you have, the handout. It's a 1-pager. It says due today. I will do any 2 questions from the front. Yeah, 4 questions in the top, in the front, and in the back you have another 4 questions. I will do any 2 from the front, 1 through 4, so I'll do 2 of those. And I will do 1 from the back, whichever one you guys think is worthy. So look at the front. As a class, between 1 and 4, give me a number to do. 2? Start with 2? Yeah, we can do 2 and 4. We can do 2 of them. All right, 2 and 4. You guys decided. Look at number 2. Number 2 says transform. So here's what they want me to do. 1 minus cosine squared x over tan x. They want me to transform that to sine x cosine x. Okay. You guys ready? Side notes. Look at your notes. I'm going to put the side note up here somewhere where it says name. Side note. I know that cosine squared x plus sine squared x equals 1. And immediately I see 1 minus cosine squared x. So if I move the cosine squared to the side, sine squared x is equal to 1 minus cosine squared x. Do you guys see that? So I can replace the top, 1 minus cosine squared, with, perfect, I heard someone say it, with sine squared x. And I still have it sine squared over 10x. Are we okay? All right. Okay, I think you guys are okay with this. I'm going to rewrite sine squared x. And I know that 10x is sine x over cosine x. Are you guys okay with that? Okay, I'll stop. I'm going to do keep, change, flip. So I'm going to write sine squared x. I'm going to keep that. I'm going to change the division to multiply. And I'm going to flip the sine x over cosine x. So it's going to be cosine x over sine x. Yeah, for those of you that are way too fast, you guys know what I'm doing, you can just do your thing. You don't have to do it this way if you don't want to. What can I cancel out? Remember, this is like sine squared x over 1. What can I cancel out? 1 of the sine x's. Bam, bam. OMG, look at that. The only thing you have left is sine x, cosine x. Put 3 little dots, shape of a triangle, and then you just write 1 minus cosine squared x over tan x is, in fact, sine x cosine x. Because you proved it right here. Does that make sense? Okay. And I think you guys said number 4. Oh, you know what? Number 4 is actually easy because you can just do direct substitution with the 1 plus cotangent x. So pick one between 1 and 3 because those you have to do a little more. 3. Okay. 3. Yeah, number 4 is a simple one because you just have 1 plus cotangent, so that you just replace immediately. Okay, secant squared minus 1. Give me, I think it was the 3rd bullet on your notes. 2nd page. Oh, look, I'll look for it. It's right here. 3rd bullet on the 2nd page, we have this formula right here. Do you guys see that? All right. So give me that formula real quick. Oh, wait. Is that one that I want? No, I want the one with a secant squared on it. So the 2nd bullet. Yeah. So side note. And I have 1 plus, what was it, tan squared? Equals secant squared. Do that. That's a side note. I do not have 1 plus tan squared, but I have secant squared minus 1, correct? So move the 1 to the other side, and then you will have that. Tan squared theta equals secant squared theta minus 1. So that's a side note that you need for this. Cool or not cool? So I'm going to rewrite it as tan squared. You know what? I need space, so I'm going to do it right here. So I'm going to rewrite this as, I'm going to put it right here. And let me change the color so you can tell what's the difference between the top and the bottom here. I'm going to write it as tan squared theta over sine theta. Are we still okay? Nothing crazy, right? And remember that tan is what over what? Perfect. And I'm going to put the square on it because the tan is being squared. I'm about to do keep, change, flip. Keep, what am I keeping? I'm keeping the tan squared, so I'm going to keep the sine squared over cosine over cosine squared together. Sorry, guys. Sine squared theta over cosine squared theta, that's my tan squared, times, keep, change, flip, that's like sine theta over 1, times 1 over sine theta. And I know some of you don't need this help. You can just go right immediately from this one. Well, how many can I cancel? How many sine thetas can I cancel? One of them. Do you guys see that? And I know you guys are saying, well, Chav, I don't see that secant theta. Relax. So now I have this. I have sine theta over cosine squared. I'm going to expand it, guys, because I have a square on the bottom. So I'm going to expand it. Chav, what do you mean by that? Here's what I mean. Sine theta over cosine theta times 1 over cosine theta. And there it is. That is sine theta over cosine squared. Do you guys see that? Chav, I don't see it at all. Okay, let me go over here. I can show you. Yeah, look, guys. Sine theta times 1, that's sine theta. Cosine theta times cosine theta, that's cosine squared. Do you guys see that? Okay, for this second. I was blocking this. Cosine times cosine, that's cosine squared. There's a dot there. Multiplying. That's how you multiply fractions, right? Top with top, bottom with bottom. Are we okay there with that, guys, or not? Okay, check it out. Look how simple it is. Sine over cosine right here. Isn't that tangent? Yeah, that's tangent. Sine over cosine. 1 over cosine. What's 1 over cosine? Secant. OMG. Look at that. So I have tan theta, secant theta. Is that what I was trying to prove? Yeah, that's exactly what I was trying to prove. So you put 3 little dots in a triangle, and you write secant squared theta minus 1 over sine theta is in fact tan theta secant theta. How do we feel? Okay. All right, go to 5, 6, 7, 8. And I would choose, okay, I'll let you know. 5 and 6 are pretty simple. They're exactly like the example that we did a little earlier. I would choose between 7 and 8. It doesn't matter which one. They're both about the same. 7? Okay. Yeah, exactly how we do 7 is how you're going to do number 8. They're both the same. All right, number 7. They're trying to prove this. They're trying to prove 1 over 1 minus cosine x plus 1 over 1 plus cosine x. And they're trying to prove that that equals 2 cosecant squared x. That's what you're trying to prove. Here's what you're going to do. I'm going to get a common denominator. So this one on the left, I'm going to multiply by 1 plus cosine x over 1 plus cosine x. This one on the right, I'm going to multiply by 1 minus cosine x over 1 minus cosine x. And I'll wait for you guys to catch up. When I do that, here's what I'm going to have. I'm going to have 1 plus cosine x. And on the bottom, 1 plus cosine x times 1 minus cosine x, that's like the difference of squares. You're going to have 1 minus cosine squared x. Does that make sense? Plus, that plus is this plus. 1 times 1 minus cosine x is going to be 1 minus cosine x. And on the bottom again, you're going to have 1 minus cosine squared x. So catch up to there. Are we okay so far? Okay. Oh, wait. Yes. No. Let me know. I wanted to find a common denominator, so I multiplied the left term by 1 plus cosine over 1 plus cosine, and I multiplied the right term by 1 minus cosine over 1 minus cosine. Yeah, right. Wait here. Let me give you an example. Don't write this down. Just listen. When you were in 5th grade, I think it's in 5th grade, maybe 4th grade. I'm not familiar with the elementary teaks, but when you did fractions in elementary, I'm sure they showed you this, and they probably said something like, "Well, I want to add these fractions up, so you got to multiply this by d over d, and you got to multiply this by b over b to get a common denominator." You guys remember that? That's exactly what I'm doing here. Just that. Is that how they taught you guys in elementary? Or? Okay. Oh, I don't know. All right. Cool or not cool? Okay. Yeah, that's like the difference of squares, right? So, okay. So here we go. I now have 1 plus cosine x. That's a plus in the middle, so I can just write 1 plus 1 minus cosine x all over 1 minus cosine squared x. So write that down. What is going to zero out? The ones add up, but the cosines zero out. Do you see how this one's positive and this one's negative? So those cancel each other out. When I say zero out, I mean, that's what I mean. Like when you add them together, they zero out. Does that make sense, guys? Okay. So when you do that, what's 1 plus 1? So you get this. And I know what you're thinking. You're like, Chop, that does not, like, I'm supposed to get 2 cosecant squared. How is that my answer? I don't understand. Well, let me show you. I guess we can do a side note, or hopefully you're already seeing it. A common theme here. Side note, bless you. Cosine squared x plus sine squared x equals 1. And I know that if I move, let's see, what do I want? I want sine squared. So if I move the cosine squared to the right, look, sine squared x equals 1 minus cosine squared x. Do you guys see that? So I don't know if you guys want to add those into your notes, into your notes 14. So let me go to notes 14 real quick. You see on this page, if you want to add like all the different combinations, you can say cosine squared theta is equal to 1 minus sine squared theta. Another different combination is a little pull dot. If we move the sine squared, so let's see, sine squared theta is equal to 1 minus cosine squared theta. And you can do that with all of them, really, right? See? And you can start moving, like you can say secant squared minus tan squared is equal to 1 for the second bullet. But yeah, see, all those are just different combinations. So don't worry, you can do that later on when you have more time. We're almost done with this one, so sorry guys. So here we go. So I'm going to rewrite this as 2 over, what is 1 minus cosine squared? The same thing as? Perfect. Yeah, sine squared of x. You can just say sine squared, and we understand each other. And then notice, Chop, that still doesn't give me that cosecant squared. Well, yeah, side note, 1 over sine squared x equals cosecant squared x. See? So I have it, 2 cosecant squared x. Do you guys see that or no? Yeah, I guess if you don't see it, guys, you can do it. I guess you can do this. Excuse me. 2 times 1 over sine squared of x. And then sine squared of x is just cosecant squared. 2 cosecant squared x. But I really don't want to, I mean, it's still correct. It's just, you're just doing more steps. So then you put 3 little dots in a triangle. 1 over 1 minus cosine x plus 1 over 1 plus cosine x does in fact equal 2 cosecant squared x. And you're going to do exactly the same thing for number 8. Cool or not cool, guys? How do we feel? Not that bad, right? You just need practice. Hopefully you'll have some fun with this, guys, because it's kind of like a little puzzle. So let's finish it. We got 50 minutes, 45 minutes, 42 minutes, I guess. 42 minutes to do 4 problems. That's plenty of time.
5, 4, 3.